We are now studying matter in some detail, and we have a model for phases, and you're probably familiar with phases already. There's solid, liquid, and gas. And the physics model is going to oversimplify each of these, and so I want to go into some detail about what's going on with this. For a solid, we're going to assume that every atom or every molecule, we're not really going to distinguish between them right now, is connected by a spring-like bond to every other, and this is effectively a crystal. So at least for intro physics, we're going to assume that every solid is a crystal where you have this sort of regular spacing, a periodic array. And we're going to assume that it's incompressible, meaning that you can squeeze it and it really stays the same size, the same shape. So that's what our solids are always going to look like. Liquids are going to have molecules or atoms that are not actually attached together in as rigid of a way, but they are attracted together such that they are condensed. And the idea being that they're held together slightly, and it is again incompressible. So it is going to have a constant volume if it's a liquid, and it's going to fill the container. As long as there's gravity, it will be filling the bottom of the container. Now there actually is a special chapter that deals with liquids that we're not covering, so in general you're not going to see liquids again. Finally, there's gases, and gases is going to be the most important phase that we're dealing with. A gas fills the container that it's in, and we're going to assume that these atoms, again, or molecules, are very far apart. It flows, it takes whatever shape of the container. That's how we can think about it as a fluid. And the big difference between a gas and a liquid or a solid is that the gas is compressible. We can take the same amount of gas and change the volume that it takes up. And that's something that's going to be important and that we'll deal with in the next few chapters. There's this idea of changing phase, which is going in between these, and we're not going to worry too much of the details of the kinetics of that, but we are going to relate it to temperature and heat. We call it freezing when a liquid goes to a solid, and that isn't just water, that's really any type of liquid and solid, and melting when a solid goes to a liquid. Condensation is when a gas becomes a liquid, and boiling is when a liquid becomes a gas. We have this idea of state variables, and this is introduced now and it's going to come back later. The book lists 5 different quantities and you're told that these are state variables. What I think is most helpful is to understand what is and what is not a state variable. Anytime we can talk about the change of something, it is a state variable. So for instance, if I have a gas, I can talk about a change in volume. An increase in volume means the gas gets larger. An increase in thermal energy will increase its temperature. Now, something that is not a state variable is, for instance, work. Work can be done on a gas, or a gas can do work, but it doesn't make any sense to talk about a change of work. Additionally, work is not a property of the gas, it's an interaction. So anytime you have an interaction, that's going to be something that is not a state variable. And the reason we care about that is because it shows you that these are interactions rather than descriptions of what's happening, and this will come back over the next few chapters. Lastly, an important definition is the idea of thermal equilibrium. This is a situation where your state variables are not changing. So you have a gas that is of a fixed density, fixed pressure, fixed volume, fixed thermal energy, temperature, and so on. Now, it's not necessarily changing because you're somehow holding it there, but it's just happily in equilibrium. Equilibrium's obviously in the name. And so this typically means that energy is not changing. I don't quite want to say that it is not interacting with its environment, but you have a steady state. So for instance, you can have a gas that has interacted with its environment and reached equilibrium with the environments that it's in contact with. Another way to think about it is you can have especially pressures that are due to an interaction, like forces between a gas and an environment, something external that's pushing on it. But once that's a constant force, if you have, say, a pressure balancing it such that then there's a net force of 0, it's then in equilibrium. So the main takeaway here is we would say the state variables are not changing. Volume, pressure, temperature, they're all staying the same, and we call that thermal equilibrium. We're going to use this term a lot, so it's important to know what it means.